quick review of the key thing from last time. We were talking about method versus function, and this was big. This was very big, so if you didn't understand this, you better. So, methods are effectively, they are like functions, but they're functions that belong to something of a particular type. And when we were playing around with strings, like this, let's connect. I'm going to call the method, I'm going to try to call the method, what was it, 2 uppercase? What is it? Upper. Right? Well, actually, first, if I were to tell you to write a function to take a string and convert it to all uppercase versions, okay, we'd write a function, it would look something like this, you know, def 2 uppercase or something, some string, then we would have something going on in it, whatever. It would look something like that, right? The general idea is the content of the function isn't what's important right now. It's the fact that we've got a function, and the idea of this function is I want it to take a string and return the uppercase version of that string. And then when I would call it, I know the content of this function is nonsense, but that's fine for the purpose here. If I were to call it, I would say, okay, to and I would call it like this. Now, obviously, when I run this, it's not going to work because it's a nonsense function, but pretend it did work. Pretend it was written correctly. That's how I would call this function. But we'll notice that in reality, I mean, I could write that function. And, you know, there's a lot of functions that already exist in Python, like print, absolute value. There's some that are inside, like the standard library, but we have to import them, like those math functions. Remember, we have to import math, and we have all those functions. Well, sometimes there's functions that are actually like attached to a type. For example, a string. I'm going to call this right here dot upper. And when we call a function like this, we actually call it a method. Because it's not a function, it's called a method. It's a little bit different, although it's effectively the same idea. Come on, run. Right? There we go. Now, why did I not call it? Like, why was the function upper like that? Why would I call it like that, not like this? Like, why is it not like that? Well, the function upper doesn't exist. But there is a method that does exist that's attached, that's part of the whole string type. So this is how I would call it. Now, when I go back to here, this is the argument, right? What value do I want to turn into an uppercase? Well, the one stored in the string, a string, like the variable a string, right? Well, why did I call it like this, with no parameters, like no arguments? Well, in this case, we have what we call the implicit argument. It's the string that we're calling it on. Which string am I telling it to turn to the uppercase? Well, the one stored in a string. That's the one I'm telling it to turn into uppercase. And if you're curious, you can see there are a lot. These are all the methods of like the strings I can get. Here's an example of a method that's called on the string a string. So I'm asking the string a string, and what's the string a string? Well, it's the value hello world. It's that string. And I'm going to look for the index of w. So here's an example of one that does take an argument. But it looks for the letter w in that string. So it looks for this value, this argument, on the implicit argument, the one that I called it on. So these are methods. At the end of the day, methods are really just functions, but they're attached to a specific type. So the uppercase, that's a function for strings. So we put it in with the strings, and it belongs there with the strings. Why? Well, it's just good bookkeeping. And this is where we get to something called like object-oriented programming, which a lot of people have really strong feelings about. It's pretty common today, but there's a lot of people that say this is really not a great style of programming. But for better or worse, if you go look at the list of the most popular programming languages, the top 8 of them are like object-oriented languages. So we're kind of stuck with it for better or worse. Now, I'm going to be very cautious from now to the end of the semester and next semester and everything to give you a lot of tips and tricks on how to avoid the pitfalls that people really hate about object-oriented programming. So we'll be clear of those, but just as an FYI. Long story short, this is a function, but I'm calling this function, this method, on a specific instance of a string. Now, if I have 2 strings here, and I were to say, we see hello world is uppercased. Why? Well, I have 2 strings, A string and B string. Which one did I tell to turn to the uppercase? How'd you know? Because that's what it literally says right there. There's no trick to it. I have 2 strings. They're both strings, but I only told one of them. You can think of this as a function like this, but the first argument in every one of these methods is the instance of the thing I'm calling it on. So here, this is like the instance of that string. This is a moment where people get really thrown off. So be aware of this. If at the end of the day you're thinking, oh great, now I need to remember what's a function, what's a method, how am I going to remember that upper is a method associated with strings and not a function? You don't. Only psychotic people would memorize all this stuff. Whenever you need to look this up, you just go and do something like how to make string uppercase in Python. Oh, there we go, dot upper. Yeah. Upper, lower, great, perfect. That's how you would do it. You don't memorize that stuff. Eventually you will memorize this stuff by virtue of just doing it over and over and over again. But don't set out to memorize this stuff. Like, oh, what's the function? Which one's the function? Which one's the method? It's important to know the difference between what a method and a function is. Don't get me wrong, that's important. But to know what particular functionality is stored as a method and which one's a function, that you'll just kind of figure out as you go. Yeah?
Did you give the upper and lower functions parameters to only uppercase certain methods?
Maybe, I don't know offhand. Let's see if we can look at it. That is an answer for the documentation. Or that is a question for the documentation, more appropriately. Let's see, upper. What's this here? It doesn't look like it. It doesn't look like it. But if we go like caseful, I don't know. I'm curious what this is going to do. Looks like it's centering the word on a line of that length, which is kind of neat. There's a lot of functionality in there hidden in methods. I've never used this one before in my life until today. It's always kind of fun to just explore. And what this should tell you is this is the level in which you need to go memorize this stuff. You don't. I've been doing this for decades, and I mean, oh, cool, that's neat, great. Maybe I'll need that one day. And if I do, I sure as shit won't remember it from today. I'll look it up again in the future. Or I'll probably write my own code to do it and then find this later and be like, shit, I reinvented the wheel. Because that's also a common thing that you'll do. Yeah, so yeah, how will we remember what's what? You don't. Any last questions before we move on? Does anyone remember the super secret strategy we talked about at the end of Friday? What it was called? No one remembers? You remember. You asked me about it on the way in. Do you remember what it was called? Perfect. And that's very important to remember. Raise your hand if you remember that. Yeah, good stuff, good stuff. You better remember that. All right. Any last questions before we move on? Raise your hand if you don't remember that. You don't? You remember that. I know you do. And I think you remember it too. Oh, you weren't here Friday? Oh. Uh-oh. You're going to be in big trouble. No, that was just a joke we were playing on the people that weren't here Friday. There's no such thing as a inverse realization. We were just screwing with you. Anyways, lists. So, we've been playing with lists for a while now, but we've never really talked about them. You've been using lists with Caddis for a while, right? And they've been in other places, like in assignment 1, there was a list. In assignment 2, there's lists with lists inside them. So there was a lot going on with lists, but we never really had a chance to cover them. Like strings, so let's create a list. Oops, sum list equals, no. A, B, C, D. Perfect. Cool. So I've created a list. I can print it out. No. We can see the list. That's how it gets printed out when we print it out. Great. And like a string, we can index a list. So what's sum list at index 0? Well, that's the letter A. What's sum list at index 3? Well, that's the letter D. What's sum list at index 13? Well, that doesn't exist, just like it wouldn't for a string. So this works the same way. Now, something that's interesting, unlike strings, lists are mutable. I can change their contents. Remember with a string, if I were to say, hey, string at index 3, change your letter to be something else, it wouldn't work. You couldn't do it. It was against the rules. If you really wanted to do it, you couldn't. The best you could do is make a copy of it and then change it when you're making the copy and save that. That was the best you could do. But with lists, you could actually go in and change the value stored there. But be warned. If you're thinking, oh, great, more flexibility. No, that's more rope that you're going to trip yourself on. We have mutability with things like lists, because a list is what we call a data structure, and data structures kind of are designed with this type of functionality in mind. Store data, update data, change data, access data, modify, all of this type of stuff. A list is a great way to store a collection of information. And so we're allowed to, it's mutable. We're allowed to change it. But we got to be careful because that can create issues. I want to make sure I'm recording. Okay, good stuff. Is it? Yes. So we got to be very careful doing this. In fact, in assignment 2, I've designed it such that you're going to pretend that lists are immutable. You never modify the lists that your functions get. You always make a copy of the list and modify it and then return the copy that's been modified, leaving the original one alone. And we pretend they're immutable. So that's a very important thing. So be aware of that. All right, yeah. Cool, great. And if I were to do this, let's see here. Let's just do this real quick. So I've got some list. We print out the list. We can see it. What's some listed at index 0? It's 5. We can slice the list, get indices 1 through 3 exclusively. We can see the type of the list. Well, it's a list. What do you think I'll see when I run that last line of code there? This line. Int. What is sum list at index 2? 0, 1, 2. Oh, that's the number 9. What is the type of 9? It's an integer. What if I were to do something like this? First of all, what is sum list at 0, 1, 2, 3? Okay, sum list at index 3 is the number 10. What is sum list at index 4? The trick is to not think too hard about it. It's that whole list. So what is the type of thing at index 3 is an integer. The type of thing at index 4 is a whole new list. And if the sum list at index 4 is this whole list, how do I get the B out of there? Well, if this is a list, I can index a list. Cool. If that doesn't make sense, consider that sum list is this whole thing. Sum list at index 4 is just this right here, and oh my God, that's a whole list. So it's almost like you can replace it with that. I mean, we could replace it with that. But sum list at index 4 is this whole thing here. Yeah, kind of, but more on that later. What else do I have here? Can we get the length of a list? Remember how to get the length of a string? We just asked len. Who could tell me the length of this of that list, sum list? Who here thinks it's 5? Raise your hand. Who here thinks it's 6? Raise your hand. No one thinks it's 6? Well, that's good because it's not. It's 5. Now, the reason you might say one may have said 6 is 1, 2, 3, 4, 5, 6. It's 6. No. It's 1, 2, 3, 4, 5. That whole list is one thing. I can make this go on for a long time. It's still 5. Because that one list, although that one list at the end of the list has a whole bunch of information in it, it still only counts as one thing on the outside list. To determine the type of the list, can a list contain things of different types at the same time? Well, evidently, yes. I've got integers, strings, a Boolean, a float. Cool. You can have a list of length 0, just like you can have a string of length 0, right? Some list, well, what is that list? Well, it's a list, but there's nothing in it. We can confirm that it's a list by asking Python, hey, what's the type of this thing? It's a list. And we can check its length by saying, well, what's the length of it? Well, it's 0. But it is a list. It's just, it's an empty list, which is very different from nothing. Nothing is nothing. An empty list is a list with nothing in it. In the same way that, now this is a bad name for the variable. Whoops. We can have a string called SumList and get its length at 0, but it's still a string, even though it's got, again, a really bad variable name because it's called SumList. Any questions about that? Another really cool thing about a list, given that they're mutable, is you can actually append things to a list. We're going to call, what do you call this right here? It's not a function, it's what? Come on, wake up. You're supposed to be well rested after reading week. Look alive, people. It's not called a function. It's called a, much better, that's good. And this method takes an argument. What do you want to add to this list? Somebody tell me, give me something. Apple. The string apple. Assuming you meant the string apple. Not the number, thanks. And now, oh great, we have the list with the contents apple. But notice that this function had what we call, this method, pardon me, this method had what we call like a side effect, where it modified, side effect might not actually be quite the right word in this particular case, but it modified SumList. It mutated it. Any idea, anything else we could append to this list? What do you want to add? True. That's a string. Oh. No, that's a Boolean. Well, how about this? We'll do it there and then down here. Oh, okay. Don't worry, it'll still be obvious. You'll see. There we go. Why is it obvious? Because it's in quotes, right? So first we start with an empty string. We append the string apple to it. Then we append the Boolean true to it. We print it out. That's the first output right there. Apple, true. On line 6, we say, now append the string false. Print it out. Apple, true, false. Great. Cool. That's what we've done. It's mutable. What will this do? When I hit run, what are we going to see? Now what happens if I do this? Take a moment and think about this. This is a fun one. Keep in mind, I just hit run, and I deleted the first line, which says SumList equals an empty string. When I hit run, what do you expect to see? This is a good quiz to see if you're following along and you understand. If you get it wrong, I'm not going to say you should feel bad about yourself, but, you know, maybe a little bit. Oh, that's fine. Let's ignore that. Ignore the squiggles. It's saying it's not defined. It's not defined in here, but yeah. Well, let's see. Is that what you thought? Because it should have been. Let's redo everything. We got some list. It's an empty list. We append apple to it. We append true to it. We print it out. In fact, let's get rid of these right here. And this right here is just going to serve to confuse you. Every time I hit run, what happens? Create an empty list, append apple to it, append true to it, print it out. I hit run again, overwrite some list with an empty list, append apple, append true, print. Run it again, overwrite with the empty list. If I get rid of this, some list still exists as far as Python's concerned. It's the list with apples and true in it. And so then I say append apples and then true. It'll just keep going and going and going. So just as a neat little FYI. All right. Now, this is something I did, pardon me, last Friday. Somebody give me a thing to put on my list. Whatever. Tell me what something. Cheese. What else? Pardon? Cat. They don't need to be strings, but we can keep going. No, I'm going with that. All right, cool. Well, give me one more thing. Shoe? What? That's the secret append. I'm not supposed to show you that one. There. Great, cool, right? Nothing crazy is going on. Well, what happens if I do this? It's a little weird, right? Here, okay, let's, sum list at index 0 is cheese. At index 1 is cat. Index 2 is 4. Index 3 is, the whole list. Well, okay, what's the thing at index 4? There shouldn't be any, okay, there's nothing there. Okay, that makes sense. But sum list at index 3 is, well, okay, what's sum list at index 3 at index 0? Cheese. Cat. 4. The whole thing again. 0, 1, 2, 3, 3, 3, 3, 3, 3. Here, how about this? You should have known what was going to be printed out. How about now? When I hit run, actually, I don't know, Python might be like, no. Nope, it's fine. It's a little weird, right? Well, we're going to explain why this is shortly, just not right now.
Why the square brackets with the dots?
Well, that's the mystery, isn't it? Because what is that? Well, it's that whole thing. Watch.
Showing that it's the whole list with square brackets and periods.
Some list is this whole list, right? At index 0, it's cheese. 1, 2, well, is 4, which is weird. But look, some list is just this. And I asked, okay, some listed index 2 is 4. Some listed index 3 is the ... But what is that? It's that whole thing. You ever do that thing where you see where you've got a camera pointing at a TV? And you can it goes inside itself forever and ever, and you can look into, or two mirrors. You put two mirrors like this, and you can see into infinity, right? That's what's going on here, right? Is what's in that list? It's a list. It's itself.
So in reality, it's just repeating itself constantly?
It's not that it's repeating itself, but I don't want to get into those weeds today. We're going to get into those weeds tomorrow or something. Pardon? Yeah. See how this goes? I don't want to change the, but see how you can even see my little mouse inside there. Yeah. If I could zoom in, which I really don't want to right now. Here, I can do this, I think. Can I make this smaller? Yeah. Nope, apparently not. But see how there's this picture and this picture and that picture and that picture and that picture and that picture forever, 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 right? It's the same idea, but with the lists, with itself inside of it. But it's not a copy. It's a little bit more nuanced than that, but we'll get to it very soon. I just wanted to tease something exciting. All right, data structures. The list is your first real data structure. But I will warn you, a list is actually a rather sophisticated and complex data structure. Next semester, which is all about data structures, we don't start with lists. Lists are near the end of the semester because they're a little bit more complex. Maybe middle to late half of the semester. But I'm going to warn you, it's great. It's very general purpose. It's fantastic. It's pretty easy to wrap our head around in terms of how we use it. They are very important. A data structure is just some structure that holds data. A list is an example of what we call a linear data structure. Linear is just a fancy way to say, if I were to give you some arbitrary list of some arbitrarily large size and say you are currently at index X, and I were to say to you, what's the next index? What do you say? Nailed it. There's an obvious well, what's next? That thing. What came before it? That thing, right? You can draw a line connecting everything. We have nonlinear examples that we will also talk about later. But lists. So here's an activity that we'll do together for fun. No, we're going to skip this activity. This is a good one. I don't know. We'll skip it for now. Mostly because it's in the lab from last week, right? So you did it already. Anyways. Remember how we were doing linear searches on strings? Look for this letter in the string. Well, we could generalize this to work with lists. Look for this arbitrary thing in a list. Same idea. So similar to strings, we can concatenate lists with plus, which is nice. So if I'm just going to do the literal list plus we get that list. Plus, on lists, concatenates them, just like it would have with strings, which is neat. And what do you think will happen if I do this? Well, we just get it repeating 10 times, which is kind of neat. Which it worked the exact same way with strings, which is pretty neat. So here's an example. Some list, some other list. I can add them together. We get a bigger list. Now, mind you that doing it like this would leave some list alone, and some other list would be left alone. The concatenation would be like a copy of them put together. Let me show you what I mean. But print some list is still some list, and some other list is still some other list. They were left alone. They didn't change. Multiplication, like I showed. And here's like we did with the strings, we could just see like, well, what methods are there for lists? So I'm just going to delete all this and say, okay, sum list dot append, clear, copy, count, extend, index, insert, pop, remove, reverse, sort. I guess that's it. There's a bunch of methods that already exist for lists, which are great. That's functionality that would be called on any particular instance of a list. Do any of these intrigue you? Pop. Well, let's see what happens if we call what did it do? Pardon? It removed the 9. So it looked like it removed the last thing in the list. So it's like, instead of like append, it's pop. So add something to the end, pop is remove something from the end. I wonder what is stored in here. What do you think? The 9. Now what's interesting about pop is you can actually specify the index you want to remove. So I could say 0. And we get rid of the 5. And what do you think is going to be stored in, you know what else is kind of neat? Now this one doesn't return anything. Maybe I can't do that with append. Maybe, oh no, it's insert. Append's always the end. Maybe I need to do 0, x. There. There we go. Cool. Again, a demonstration of how much you should realistically expect to memorize these things. You know, it takes 2 arguments. What's the order? I don't know. Really what I should have done is I should have done this and go, oh, the index, and then the, okay, yeah, right, yeah. How would I use the copy? Let's see. So, now, this actually leads to a very interesting thing that we will cover in more detail later, but I'm going to show you because someone brought it up and it's a good question. So I do this, whatever, right? We see some list printed out. Like, what's the big deal, right? I said some list. Some list is the list 5, 6, 7, 8, 9. Then I say sumList.copy, and I save that into the copy list variable. I print out sumList, and I see 5, 6, 7, 8, 9. And I print out copy list, which we see 5, 6, 7, 8, 9. This shouldn't be that weird. But you might be wondering, like, why do I need this copy method? I could just do that. Right? Why do I need this whole extra method to copy it when I can just do that? Well, who wants to be mad? Everyone put your hand up because you're about to get mad. Watch what happens if I do this. Some list at index 0 equals x. Okay, right? Look at that code. Look at this code. Make sure it makes sense, right? Sum list 5, 6, 7, 8, 9. Sum list.copy. Okay, we get a copy of it. Then we go to sum list, change index 0 to an x. Print out some list, we see X, 6, 7, 8, 9, and then copy list is 5, 6, 7, 8, 9. Cool, whatever. But what happens if I do, instead of the dot copy, which we saw did like the same thing a moment ago, except it didn't. Oh. Yeah. Yeah. Now, I want to be very clear. This makes perfect sense. It absolutely does. And if you're like, what? No, I don't like it. You either will like it or you'll deal with it. Because it's the way it is. Okay? So get used to it. And this does make perfect sense if you know what's happening. And we're going to discuss what's happening probably tomorrow. We're not going to get to it today. But a teaser into what is happening is when I have the variable sum list, and I say, what's stored in the variable sum list? And you say, well, it's the list. Let's hit pause on that. Let me take a step back. If I go down here and I say A equals 5, and I say, great, what's stored in A? 5. Great. When I run this and say, okay, what's stored in sum list? The list 5, 6, 7, 8, 9. Wrong. That is not what's stored in that variable. What's stored in that variable is what we call a reference. Because remember that whole thing with strings? I can store the number 6 in this seat. Easy peasy. I can store the value true, Boolean, in this seat. Very easy. They fit nicely. But if I give you the string hello or the string of the whole contents of your favorite book, they're not going to fit in a single seat. I have to come up with a creative solution where I put each letter in its own seat, and I got to keep track of where that series of letters begins. That's the root of where this all comes from. But we're going to get to this in detail shortly, just not right now. But any questions about that? This is your fault. Because you asked about copy. Yeah? If you want to copy the list a number of times, that would really depend on the context. That would be very dependent on the specific context of what you're doing. Because I could just put it in a loop and be like, repeat this code like 100 times. Or if you mean like times 100, right? Now I've repeated it several times. It really depends on the specific question you have. That's a very open-ended question. Yeah. Other questions? Can you be more specific with your question, or are you just curious?
I was asking, like, using the copy method, like, using the copy the number of times, using that method.
So, oh, you mean like if it takes an argument? There is no arguments to this, so we can't do it directly with this method. We need some extra code to address the specific needs that you have. Now, you might also notice that this says returns a shallow copy of the list. Shallow? What the hell is a shallow copy? And if something's a shallow copy, is there a deep copy? Yeah. Yeah. No, but it's connected to that. It could. More on this shortly. Okay, mutability. Although lists and strings have some things in common, lists are mutable, as I showed you. Lists and loops, like with a for loop, where I can say for letter in right? I could do that. For each, remember, a for loop like this is literally just for each thing in a collection of things. Well, a string is a collection of things, more specifically individual letters. But I can turn this into a list. And it will iterate over that just fine. You did this in assignment 1. For each pair of latitudes and longitudes, you checked, was it in that box? Right, for assignment 1. You're going to do it a bunch for assignment 2. Range, by the way, some of you were already familiar with this. Sometimes you have a for loop. You could use range in a for loop to just have a loop run some number of times. Now, to be clear, I don't need to use the I here. I could say print out the letter I. Well, how many times did that letter I get printed out? Who can tell me? 3, 2, 1, 10. How'd you know? Why? Well, it said right there, for I in range 10. If I put a 100 in here, how many I's do you think is going to be printed out? 100. Nailed it. Do you want to count them? Didn't think so. Well, we'll have to trust Python on this one, right? So range is an easy way to make a for loop run some number of times. But in actuality, really, the range works the same way as it would had with the list. Because really, now if this was Python 2, this would be a little bit more obvious. Python 3 made a change that makes it slightly less obvious. But range of 10 effectively gives you a list starting at 0 going to 10 exclusively. And if I have a list of the numbers 0 through 9, and I say for I in list of the numbers 0 through, for each thing in a collection of things. So that range is basically working the same way as the other for loop. This range, by the way, I want to be very clear, even though like I'm kind of rushing through it, this is a big one. You're going to want to know range. It comes in handy a lot for iterating over a for loop. It's basically syntactic sugar for a while loop that looks like this. Start I at 0, while I is less than 5, print out I, increment I, right? I could do that with a for loop like this. And look at that. It's 2 lines of code. That's 4 lines of code. It's literally twice as bad, right? So it's saving you so much time and energy. It's just syntactic sugar, though. That's all it is. If you hate range and you're like, no, I'm sticking with my while loops, more power to you. Awesome. But they are functionally equivalent. Skip this one. I won't skip this one. This is where we'll pick up tomorrow. Do we have any questions before we wrap up? All right, you saw the emails I sent about assignment 3's due date and test 2. They exist now. See y'all later.